Alright then guys, so let's pick up the notes from where we left off yesterday. As a reminder, from yesterday when we finished reflections, so don't start a new set of notes. Like this is where we left off. This is where we left off. Just continue from there. Don't start a new set. We're gonna go into rotation. Please. In fact, as you guys are writing that out, let me pass out the word. Alright, so once again, today we're going to be looking at rotations. So I just pass out the worksheet so we can move on after we finish this. But an explanation of rotation. It says a rotational transformation that turns a figure about a fixed point called the center of rotation. Right, so let me show you guys a picture. If we see the F, here my center of rotation will be the origin. What that means is if you were to hold the origin, you spin the paper. And then F will turn something like that. Right? My center of rotation in this case will be the origin. But I can make it any point. I could make it the point 40 and then spin everything around that. So that when I come and say rotation about the origin, it is important. That phrase about the origin is important. Because that means that's the point I'm holding. Everything else spins around that point. And then figures that get confused are rotations. You guys see my rotation with reflection. People confuse those a little, and I don't know why. If you notice, starting with, let's say I start here in the first quadrant, and I rotate this about the origin. So I was to hold the origin and spin my paper. You guys see how my R finishes in rotation. In reflection, it finishes way different. One, it finishes in a different quadrant, and two, the facing outward. On reflection, it looks like the front of the art is to the right. On reflection, it looks like it's towards the left. So they are different. People confuse them, but they're not even close. They're different. Let's take a look at a few examples. So don't copy this. Let me just explain it. Imagine I have this figure here, my center of rotation, and I was to spin it to the left, 90 degrees. It looks like that. Since I can spin it towards the left or towards the right, we're going to call it clockwise or counterclockwise. Right? Clockwise means we're going in the direction of the clock. Counterclockwise means we're going against the clock. So those are going to be, that's how we're going to call this. And we're going to call it in degrees. And then we're going to use, I'm only going to use 90, 180, and then 90 clockwise, 90 counterclockwise, and 180. Those are the only ones that I can do. I will do. One thing that we can do for rotation, I can copy on the axis, my center of rotation, it looks like a cross. I can copy my picture. Let's say I had a paper on it, hopefully a patty paper or something I can see through easily. And let's say it was like this, facing normally, and I drew my cross where my y-axis overlaps the x-axis going towards the left, I'll be 90 degrees. So that's how it's done, but we're going to learn a few formulas. So going back to how we did yesterday, remember how I gave you guys the coordinates of B, and then I gave you guys the coordinates of B prime. So we're going to talk about rotation. So do me a favor and copy the next rule. Rotation of 90 degrees clockwise about the origin. XY becomes, and then you guys will help me finish that. So I'm going 90 degrees clockwise. And if you look at the picture, looks like you turn the paper 90 degrees clockwise. So the rotation of 90 degrees clockwise about the origin, xy, becomes what? Y negative x. Good. For abbreviation, clockwise, for abbreviation, let me abbreviate that as CW. Clockwise. Yes. About. About. What it means about is like that's the point we hold. So, once again, clockwise, I'm going to abbreviate it as CW. Counterclockwise, I'm going to abbreviate it as CCW. Counterclockwise. Alright, so the other one we're going to see is 90 degrees counterclockwise. So let's write this rule. Rotation of 90 degrees counterclockwise. And remember, for counterclockwise, you guys can abbreviate it as CCW. Or counterclockwise. Rotation 90 degrees counterclockwise above the origin, xy becomes what? Negative yx. Perfect. These rules are going to become very important in a minute. The rotation of 90 degrees counterclockwise about the origin. Remember, the phrase about the origin is important. Because that's the point that it holds. Xy becomes negative yx. The other one, I'm going to go for 180 degrees. Rotation of 180 degrees about the origin. Like this one I don't specify clockwise or counterclockwise, because either or is the same thing. Rotation of 180 degrees about the origin, xy becomes what? What do you guys think? What is it? Negative x, negative y. Perfect. You notice all we did was just change the signs on the coordinates. So 180 degrees is going to become negative x, negative y. Right, so those are only the three that I'm going to cover for rotation. We can rotate any degrees that we want. But these are special cases. We can follow with the coordinates. The others, there's really no relation on the coordinates of those. So by now, you guys should have a table that looks something like this, little by little. First, we started with translation. We learned the rule for translation. Yesterday, we talked about 4 reflections and then 3 rotations today. So little by little, probably not in this format, but in your notes, you guys should have this table broken down little. Do I expect you guys to memorize it? Not necessarily. Don't memorize it. As a matter of fact, I have it here on the board. Just learn how to use it. Okay, don't memorize it, just learn how to use it. So for us to learn how to use it, let's practice on our worksheet. Looking at question number 1. Looking at question number 1, it says, graph the image of the figure using the transformation given, rotation of 180 degrees about the origin. First of all, if I know how to deal with coordinates, let me get the coordinates as they are. The coordinates of H right now is negative 2, negative 1. So I'm going to get the coordinates as they are. Then, let me get the coordinates of G, which is negative 5, and I is 0, negative 5. I'm getting the coordinates the way they are right now. I know for 180 degrees above the origin, we learned that xy becomes negative x, negative y. So for h prime, I'm going to get positive 2, positive 1.
So it's basically the opposite.
Opposite sides. 180 degrees is opposite sides. For g prime, I'm going to get 5, 5. What do you guys get for I prime? 0, positive 5. Now just plot those points in. Don't forget to label them. Connect your points. And if you notice, if imagine this is paper, this was a paper and we spun it 180 degrees, it will finish like that. Rotate it 180 degrees above the origin. Once again, with above the origin is you hold the origin and you spin everything around. Any questions on the first four? Number four? Alright, so looking at number four, 90 degrees counterclockwise. First, let me get the point as they are. The D is 2, negative 2. E, I have 2, negative 4. And C, I have negative 3, negative 4. Those are the points that I have. For 90 degrees counterclockwise, I know that xy goes to negative y, positive x. Right, that's the rule that we learned. So for d prime, I will get positive 2, positive 2. What do you guys get for e prime?
4 and 22.
4 and 2. What about c prime?
4.
4 and negative 3. And then plug those points in. You see how xy becomes negative yx. So there's flipping, xy becomes yx, but change the sign on the y. And then c, so it looks like you turn this 90 degrees counterclockwise. Yes. Okay. Not necessarily always positive. In this case, it is positive, but not always positive because if you notice on the rule here, it says negative y. So basically, whatever the value y was, just change the sign. It happens that all of our y's were negatives, so when we switch the sign, it became positive. But in some cases, we might have some negatives. All right. So we're good for the first one?
There's some,
Yes.
like on number 2, since there's already like, for example, point G is 2, negative 1, does it just become negative 2 1?
2, negative 1, right? So that's G. G prime, because it's 180 degrees, will come negative 2, positive 1?
Yeah.
Yeah.
Wait, how come the formula is
It's different degrees, different formula. Alright, so we're good in the first one? Alright, let's take a look at question number 5. Once again, I know in your paper there's no bucket clue, but you guys can follow the notation. You guys know which one came first, which one came later, because of the notation. So it says describe a rule when we write a rule to describe each transformation, we're dealing with rotations today, so I'm just going to write rotations, or rotation of, I need to find out the degrees, the rotation of, since it happens to every point, let me follow my W and my W prime. You notice the coordinates of W right now are 4, 3. W prime is negative 3, 4. So for us to understand it better, x, y, when I change this, became negative y, x. Or x, y became negative y, x. So which rule is that?
Rotation of 90 degrees counterclockwise.
Rotation of 90 degrees counterclockwise. So let me write this. 90 degrees counterclockwise. Remember, I'll abbreviate counterclockwise about the origin. I remember when we started looking at translation, and I just told you guys at the beginning, write translation. At the time, it was the only thing we were learning, but I will tell you guys, still write translation because it will make more sense later. We notice now we have reflections and we also have rotation. So the first word is very important. Right? today, but so I have rotation of 90 degrees counterclockwise above the origin. And for, once again, for rotation, the phrase above the origin is important. All right, any questions for the example number 8? Like number 5, I followed those views. We could have followed any other question. Let's take a look at question number 9. Question number 9, 90 degrees counterclockwise. For me to remember the rule, x, y, and 90 degrees counterclockwise becomes negative y, x. Right, that's what our rule tells us. So find the coordinates of the vertices of each figure after the given transformation. For E prime, what do you guys get? 1, 0. For D prime, what do you guys get? 0, 0. For C prime, what do you get?
0,
0, 3. And for B prime, what do we get?
3,
3, 4. Look at my D and my D prime. We cannot tell the numbers flip, right? 0, 0, they don't, you cannot tell they flip. Another thing we cannot tell is if we change the sign of one of them. We cannot tell. So whenever we're asked to compare points, avoid zeros. Because on zeros, you don't know if they flip or not. Obviously, also avoid having the same value for x and y. Because you cannot tell whether they flip or not. So avoid zeros and avoid the same value for x and y whenever we have to compare ordinance. What I mean with that is, let me take a look at the last section, looking at question number 13. Write a rule to describe a transformation. When I'm comparing those, avoid zeros. We don't know if we change the sign or not. And avoid the same number for x and y. So let me compare my u with my u prime. It looks like xy became negative x, negative y. Right, it looks like I just flipped the sign. I just changed the sign. It seems like that's all we did. Which rule is that one? 180 degrees above the origin. So when it says write a rule, I'm just going to write, let me write it up here, rotation of 180 degrees above the origin. When it was 90 degrees, it's important you tell me clockwise or counterclockwise. But for 180 degrees, it does. Right, so we have the paper, if I go one direction, 180 degrees, this way. If I go the other way, 180 degrees, I finish with the same thing. So 180 degrees is not necessarily important, but for 90 degrees it is. I want to know 90 degrees counterclockwise or 90 degrees clockwise. All right. Any questions? Yes. 11. All right, let's take a look at number 11. So here it says find the coordinates 90 degrees counterclockwise. I know the rule says xy becomes negative y x. So for L prime, I'm going to get 2, negative 3. What do we get for K prime? Negative 1, negative 5. What do we get for J prime? Negative 3, negative 4. And lastly, I prime, 2, negative 2. Okay. So yesterday we learned reflections. Today we learned rotations. Tomorrow I'm going to review both. So kind of like this case, when it says find the coordinates of the vertices of each figure at the given transformation, I will have both. And then basically the worksheet that you guys have right now, I'm just going to make it a little bit bigger, right? More questions, and then reflection and rotation only. And on Thursday, all three, including translation. And then we have a quiz on Friday. Any questions? Let me take roll really quick.